Welcome to the simple interest and compound interest lesson. So we are now starting our finance unit. All right, so today's learning goal is we're trying to compare and differentiate between simple and compound interest. So I just wanted to kind of go over just what we're just doing in general. So we're taking some money. So a lot of you guys have jobs right now, and you're going to put it in the bank. Okay, so say you want to save up for something or you just want to keep it safe and so forth. So I want you to think of your money as being a little worker for you. Okay, so you're sending them out, putting them in the bank here, and they're going to make money for you. And then you're going to eventually, take it out, or at least look to see, what they've made and so forth. Okay, so you have a certain amount, you put it in the bank. Okay, and then you're gonna take a look after a little bit of time and then just see how much money that you have. We're gonna look at simple interest and compound interest today. So before we do that, I just wanna go over some of the terms that I'm gonna be using so that you will understand what I'm talking about when I say principal or amount and so forth, okay? So you are starting off with some initial amount of money, okay? So this is your initial amount. And they like to use a fancy word called principal for that. Okay, so we're going to take the principal and put it into the bank. Okay, so they also call this the present value. Okay, so that's why if you're taking some more courses in finance, this way you'll know what they're talking about. Okay, so I'll usually say principal, but I'll try to use present value as well, just because that one makes sense. It's like right now, this is how much you have. Okay. But principal is used a lot. When they're referring to things like on your bank statements and so forth. Okay. All right. Amount. That's what's going to come out here. Okay. So there's some money that's going to come out, and we're going to look at the amount. Okay, so that's after. So after sitting in the bank doing work for you, your little worker money comes out and brings home money for you. Okay, so that's analogy to think of it. Yes. So all right. So this is I guess if we're trying to match the words on the other side, think of this as the final amount. Okay, but yeah, I'll usually say amount like that, and this is future value. Okay, so future value just makes better sense as well, but you'll see usually they'll say amount. Okay, so future value, that makes sense. You're going to send your money into the bank, it's going to work for you, and then when you check on it later, it's how much you'll have in the future. Okay, if you leave your money in the bank. Okay, so what's happening here is you start off with some money, put it in the bank. You're going to end up with the money that you had at the beginning, but on top of it, you're going to have some extra money. So that extra money, they call it interest, okay, or accumulated interest. So that's what they have here. So we're going to look at calculating interest today. So here, we can even add that here. We could say we're going to add interest onto here. Okay, so just for keeping your money, you didn't have to do anything. You just left your money in the bank. They paid you money for doing that. Okay, so it's great that way. So simple interest, there's that one, and then there's compound interest. Okay, we're going to look and compare those today. All right, so simple interest is it's the money paid on, so you put some money into the bank, they pay you a certain percentage of that amount of money that you put into the bank, okay? So if we take a look here, here's our diagram. So say we put $100 in, okay? We put $100 into the bank. And then, so what's happening here is after 1 year, when we check, you've made $50 because the percentage that they're going to pay out is 50%, okay? So that's 50% of your principal is $50. So again, this is a really, really nice percentage. I don't think you'll ever see something like that on your bank statements and so forth. But anyway, we're just using this as an example. It's easy to calculate 50%. Okay, so again, so when you first started, okay, there was $0. Okay, all right, and then this is where you put in $100, right? So I guess we could think of it as, okay, you start off with $100. Okay, 1 year later, you now have $150. So what did you do? You made $50. Okay, so you left your money in the bank account and then you made $50. So you're good to go. All right, so, but then you decide to keep it in there another year. Okay, so they're still going to give you this same simple interest. So what's happening here from year one to the next year is that they're going to go back to your original amount of money that you deposited and give you another 50%. Okay, so that means you add another 50. Okay, so now again, when you go and check up on your money, you now have $200 in there. Okay, so it's slowly growing, but each year you're getting 50% of the original. Okay, so again, if you wanted to leave it in there one more year before taking it out, again, you will only get 50% of your original amount that you added at the beginning. So now you are at $250, like that. So that's how simple interest works. Okay, so they just keep calculating the interest on the original amount that you deposited at the very beginning. Okay, so it's still great. You left $100 in there and you made $150 for doing nothing. Okay, so you just had to leave the money there. All right, so compound interest is the other interest. So this interest here it's paid on the principal, that's the original amount, and any interest that's accumulated. So let's take a look at that visual here. Okay, it's this one here. So just ignore the fact that this is factory. So this is compound interest. So again, same scenario. Right at the beginning, before a year went by, you started with $100, okay, in the bank account. So you left it in there for 1 year, and because again the compound interest is the same, it's 50%. You made $50 in that first year. Okay, so now if we want to look at, we leave it there for another year, how much money are we going to make, okay? So you're going to, now what happens, so again, so the interest is 50%, right? So, in the first year, we took 50% of 100, and that's what you made. So now that you have 150 in there, the new part with compound interest is that, again, they're going to take 50% of your 100, okay, which is $50, okay, but then, of 100, but then they also take 50% of the interest that you made, and that's $25, okay, so now you end up with $225. Okay, so now if you're just comparing with what we had above here, so after the first year, okay, we both had, for both different types of interest, we had the same amount, 150, but look what happens when we leave it there the next year, okay? So we only made 50 with the one above because it was always calculated on the original principal here. But the nice thing about compound interest, it was calculated on the original principal, that was a 50, but then it was also calculated on the interest that we got in that first year. So we made an extra $25. So we're already $25 ahead of leaving your money in this type of account. Okay. All right. So let's see what happens in the last year here. Okay. So again, we're going to take 50% of the principal. So that's $50. Okay. And then we are going to take 50% of the first interest here. Then we're going to take 50% of the second interest and 50% of the third interest that we had. Okay, so that's 12.5. All right, so now we end up with $337.50. Okay, so leaving it in these different types of bank accounts, this one you end up with a lot more money, and this one you end up with still extra money, which is nice. But hopefully you're seeing here compound interest is great because you keep kind of piling up money on the total amount of money that's in your account, and then you go to the next year and then you pile up on top of the money that you already had and then pile up onto the next amount. Okay, where here it was always like, go back to your original. Oh, you put in 100, so I'm just going to award you 50. The next year I'm going to award you 50. Okay, but here it's like, I'm going to award you 50, I'm going to award you 75. The next year I'm going to award you $112.50 just for leaving your money in there for 3 years. Okay, so if you look at the difference here now, okay, between the compound and the simple interest. So if you subtract them, it was, 337, subtract 250. You ended up making $87.50 more by putting your money in the compound interest, okay, account, where like you kept it in for the same amount of time. But yes, when you had a compound interest account, it's nice because it just keeps piling on top of whatever you have instead of piling on top of the original amount that you added. Okay, so that's why they call this one simple interest and they call this one compound interest. Okay, so now that we've seen a visual example, we're going to actually go to formulas here. I just wanted you to be able to kind of understand what you're doing today, just because like I know we haven't done any finance this year, so it's just a nice transition into here, just by being able to kind of understand what you're doing and then why, one way might be better than the other way. Okay, so again, you're working, you come home, you get some money from your boss, you're going to put it into the bank. You're not in any rush to spend it, so you're going to leave it there. You're going to find it. Your goal is to try to find the best account to put it in, obviously, and then they will pay you interest if you just leave it in there. You don't touch it. You don't keep like buying stuff and taking money out. They'll pay you interest. Okay. And again, I'm not saying you all have to save all your money. It's a good idea, but what you can try to do actually is you can always open a couple different accounts, and we'll look at that next day, where there'll be one account where you just dump your money into and you leave it there, okay, and then the other account can be the one you can shop with and so forth and buy little things here and there, okay, but still then you're putting away some money and then you just don't think about it, you don't touch it, and the nice thing is the bank will reward you with that. Because if you leave your money in the bank, that means they have some money that they can lend to someone else and so forth, okay? So you're going to borrow money from the bank, okay? So if you borrow money from the bank, it's the same idea when you have it in your pocket at home, or, maybe you bought a car with it. They are now, because it's not necessarily at the bank, it's now in your car. So they'll charge you interest, okay? And then at the end, you have to pay back more money than you actually borrow at the beginning. So it's the same idea, and so forth. Okay, but we're going to look at a lot of things like this where we're investing money at first, just because I think that you guys are more likely to, just save up stuff and then maybe eventually start buying some big items. Okay, so here are the formulas in order to calculate the total amount, the future value, using simple interest and the future value total amount with using compound interest. Okay, so again, we're going to use this formula today. With the compound interest, we're just kind of do what we were doing with the pictures up above. Okay, and then we'll actually look at this formula in more detail next day, like just as a day 2 compound interest lesson. Okay, all right. But before we get to calculating some numbers using the simple interest formula, I want you to just practice converting your decimals, your percentages to decimals. So you're going to be given an interest rate, and you have to use that, but you have to change it to a decimal before you use it. So in order to do this, you need to just divide any percent by 100. Okay, so divide this by 100. So when you do that, you will get 0.0375, like that. So, and I think you probably have converted percents so often that you could probably convert to that pretty easily. Okay, all right, so here's the next one. Again, divide by 100 and you get 0.042. 2. Okay, so you're seeing a pattern here. But then it gets tricky when you look at interest rates like this. Okay, so again, these are pretty nice interest rates, but you will find that you will probably get ones like this instead. So, so you just need to be able to calculate using the correct value, but the percentage as a decimal. Okay, so again, you're still just dividing by 100, but it might be a little bit trickier to just calculate that in your head. So you are going to be using this number instead. So 1, 2, 3, okay, so 0.003. All right, and so what you're noticing here is, if you can think of it as looking at the decimal here, I guess, and like you're moving it a couple spots, I guess. That's another way to calculate these as well. All right, so here this one is 0.0025. Okay, and then you're dividing it by 100. So then you go 0.00 like that. Okay, so you're going to be using values like that. So just remind yourself it's always divide by 100, and then you can get to the decimal value. Okay, so now that we've kind of got the decimal and the interest rate kind of sorted out, I want you to go through and now look at our first simple interest question here. So I want you to determine the value of a $2,000 investment after 4 years, okay, at 5.5% per year simple interest. Okay, so again, you have your little bank here. You're putting in $2,000, okay? The bank's going to award you for that, and then you need to figure out how much money are you going to have at the end. If we leave it there for 4 years and the interest rate is 5.5%, okay, so you're getting 5.5% in the bank and you're leaving it there for 4 years, how much money will you have at the end, okay? So what you can do here is kind of write out all the things that are given to you. So I like to write G for given. Okay, so you have 2,000 to start with, right? So that's it's the principal, and you need to find the amount here, right? So let's just write that out here. Okay, so the principal is $2,000. Okay, we have the time is 4 years that we're going to leave it in the bank. And then we have an interest rate of 5.5%. And again, this is simple interest, okay? All right, so again, we're not going to use this percent number. We're going to divide by 100 and use this value instead when we're doing our calculations today. All right, and I'm going to write R for what's required. We need to find the amount. All right, so so I'm going to call this the grasp method. So if you're wondering what I'm doing here, grasp, okay? Okay, so given what's required, now we're going to do step A. So step A is kind of like your plan. What is your plan on how you're going to go about solving this problem? So what we can use as our plan here is we're going to think of what equation can we use, okay? So if we look up here, we have our A equals P, okay? So A equals P bracket 1 plus RT. Okay, so this is the simple interest formula. So we're going to plug everything in and calculate A. So S is okay, let's put our plan into action now. So let's start actually plugging in these numbers. So we know that the P principal is $2,000. Okay, so let's add that in. So we're going to put $2,000 here, right? Bracket 1 plus R. Sorry, I wrote I for interest, but R is this value here. Okay, R is your percent as a decimal. And then times time, which is 4 years. Okay, and then bracket. All right, so go through, use BEDMAS. Okay, look inside the brackets first. Let's calculate this part first. Okay, so 0.055 times 4. Okay, so this becomes 0.22, like that. All right, so BedMath says, so, do the brackets first. So within the bracket, we did the multiplication first. Okay, so now we can add. So then that becomes 1.22. Okay, so now that we've taken care of the stuff in the bracket, now we can multiply these. Okay, so it becomes 2,440, like that. Okay, so that is now your new amount. So you put in $2,000, you left it there for 4 years. Your simple interest rate was 5.5%. So every year they were going to give you 5.5%. But you did this for 4 years, so you ended up with $2,440 when you were done. Okay, so you made an extra $440. All right, and then so from there, our last step, P, is our final statement. So therefore, the value of the investment is $2,440, like that. And if you wanted to write amount of the investment here, that would have been okay too. Okay, so before actually we go to the next problem here, I wanted to just kind of go back over and just complete this question kind of like what we did with those pictures above. So remember we started off with 2,000, and then if we calculate 5.5% of 2,000, so we just have to multiply 2,000 by 0.055, like that, you will make $110, like that. Okay, so remember that was time 0, so 1 year later, you now have $110, okay, extra in your amount of money, the 2,000 you invested. Okay, so what if it's another year later? So remember that when it's simple interest, you always go back to the original amount, which was the 2,000, and again, we're calculating 5.5%. So if we calculate 5.5% back on the original, so then again, you are making 110 the next year. Okay, so then you end up with 2,220, okay? All right, so then what happens if we leave it one more year? So like that. So again, it's back to the original. You're not going to calculate just because you have extra money in here. You go back to the original. And again, so you have another 110. So you end up with that much money, okay? All right, but then we kept it in one more year. Okay, so again, it's simple interest, so that means you have the same interest every year. So then you end up with 2,440. Okay, so this is another way to calculate the simple interest. If it makes better sense to you this way, even though if I give you a formula it doesn't make sense this way, you can do that. The only issue is, what if you kept your money in there for 25 years? This is a lot of calculating, so that's why I recommend be able to use the formula as well. Okay, so what you're finding here is that so every year it's the same amount building up, and then you end up with an extra $440 when you leave. Okay, so that was simple interest. So now let's look at a problem where we have compound interest. So again, it's you're leaving our money in, and we are now going to pile on top of the original amount, but on top of it, the interest amount as well. Okay, so let's take a look here. So we're just going to do this without the formula. We're just going to just do it more visually, just like I had before. So again, we have our principal amount, so we can kind of list off everything that we have. So we have our principal amount, which is 1,500. Okay, we have the time is 3 years, and then we have the rate was 7.5%. Okay, but you're compounded annually. Okay, so you always have to pay attention to it, whether it says simple or interest or compounded something. Okay, compounded annually in this case here. So All right, so what do we have to find? We still have to find the amount again. Okay, so we're not going to use the formula. We're just going to, so we can call it the A and the S step. Okay, we're just going to kind of just do it just like the picture that we looked at. Okay, so we start off like if we're thinking about the time. Okay, so at 0 time, so initially, this is how much money you have, I guess. Okay, so you have 1,500 that you're putting into the bank. Okay, so you're going to leave the money there for 1 year. Okay, so 1 year later, how much money will you have? Well, you are going to get 7.5% interest here. So let's just write that. Yeah, so I'll just put that down here, I guess. You're getting 7.5% interest here. So if I calculate that, I'm going to just change 7.5 to a decimal. And so I'm going to use this number and I'm going to multiply by the principal here. So 1,500 times 0.075 is $112.50. Okay, so after 1 year, you now have $1,612.50. Okay, all right, so remember, we're doing this for 3 years now, okay? So, all right, another year later. So what's going to happen here? So you're going to take, again, 7.5 for this, which is $112.50. You are going to take 7.5 also of the interest that you made. Okay, so let's somehow write that here. So it's like you have to take you have to multiply, I guess, like 7.5% of this number as well. So if we do that, so $112.50, if I multiply it by 0.75, I'm going to get $8.44. Okay, $8.44. Okay, so if I have $8.44 plus my $112.50, and then I add it to the original amount that I have, I will now have okay, so before actually we go to the next problem here, I wanted to just kind of go back over and just complete this question kind of like what we did with those pictures above. So remember we started off with 2,000, and then if we calculate 5.5% of 2,000, so we just have to multiply 2,000 by 0.055 like that, you will make $110 like that. Okay, so remember that was time 0, so 1 year later, you now have $110, okay, extra in your amount of money, the 2,000 you invested. Okay, so what if it's another year later? So remember that when it's simple interest, you always go back to the original amount, which was the 2,000, and again, we're calculating 5.5%. So if we calculate 5.5% back on the original, so then again, you are making 110 the next year. Okay, so then you end up with 2,220. Okay, all right, so then what happens if we leave it 1 more year? So like that. So again, it's back to the original. You're not going to calculate just because you have extra money in here. You go back to the original, and again, so you have another 110. So you end up with that much money. Okay, all right, but then we kept it in 1 more year. Okay, so again, it's simple interest, so that means you have the same interest every year. So then you end up with 2,440. Okay, so this is another way to calculate the simple interest. If it makes better sense to you this way, even though if I give you a formula that doesn't make sense this way, you can do that. The only issue is, what if you kept your money in there for 25 years? This is a lot of calculating, so that's why I recommend be able to use the formula as well. Okay, so what you're finding here is that, yeah, so every year it's the same amount building up, and then you end up with an extra $440 when you leave. Okay, so that was simple interest. So now let's look at a problem where we have compound interest. So again, it's you're leaving our money in, and we are now going to pile on top of the original amount, but on top of it, the interest amount as well. Okay, so let's take a look here. So we're just going to do this without the formula. We're just going to just do it more visually, just like I had before. So again, we have our principal amount, so we can kind of list off everything that we have. So we have our principal amount, which is 1,500. Okay, we have the time is 3 years, and then we have the rate was 7.5%. Okay, but you're compounded annually. Okay, so you always have to pay attention to it, whether it says simple or interest or compounded something. Okay, compounded annually in this case here. So, all right. So what do we have to find? We still have to find the amount again. Okay. So we're not going to use the formula. We're just gonna so we can call it the A and the S step. Okay. We're just going to kind of just do it just like the picture that we looked at. Okay. So we start off like if we're thinking about the time. Okay. So at 0 time, so initially, this is how much money you have, I guess. Okay, so you have 1,500 that you're putting into the bank. Okay, so you're going to leave the money there for 1 year. Okay, so 1 year later, how much money will you have? Well, you are going to get 7.5% interest here. So let's just write that. Yeah, so I'll just put that down here, I guess. You're getting 7.5% interest here. So if I calculate that, I'm going to just change 7.5 to a decimal. And so I'm going to use this number, and I'm going to multiply by the principal here. So 1,500 times 0.075 is $112.50. Okay, so after 1 year, you now have $1,612.50. Okay, all right, so remember we're doing this for 3 years now. Okay, so all right, another year later, so what's going to happen here? So you're going to take again 7.5 for this, which is $112.50. You are going to take 7.5 also of the interest that you made. Okay, so let's somehow write that here. So it's like you have to take, you have to multiply, I guess, like 7.5% of this number as well. So if we do that, so $112.50, if I multiply by 0.75, I'm going to get 8.44. Okay, so when you add those up, you end up with $1,733.44. Okay, so but we want to leave it in there for 1 more year. Okay, so again, you're going to take your 2 interests that you already had. Okay, so that takes the interest of what you originally had. Then you're going to take the interest that you got in the 2nd year. Okay, so now that we're in the 3rd year, you're going to take the interest on top of these 2 interests, right? So we're going to multiply both of these by 7.5. So if I do that, I'll get another 8.44 here. Okay, and then if I take the interest on this one here, that'll be 0.63. Okay, so now we're taking all of those and adding it to our previous amount. And now, after 3 years, we're going to have $1,863.45. Okay, so that's how we calculate compound interest. It might seem a little disorganized to some of you, so what I'll try to do is I'll make a table now and show you a table way as well. So again, you start with an original 1,500. So in that first year, you gained 7.5% interest, and then you had this total. In the next year, you are going to get the interest from your original. There it is. But then you also get interest from the interest that you made. So there's the $8.44. Okay, then you add it, you get your new total amount. All right, in the next year, so same thing, you get this interest from the 1,500. You get the interest from the interest, which is the $8.44. Okay, that's carrying forward. But then you get to calculate the interest on these two new ones, right? So the interest on there, so you take this one, and then you get a grand total of that. Back in our descriptions here, there is something called the growth factor. We'll look at compounding periods another day, but the growth factor is the number that's going to be multiplied to the principal, which is the P, when you're calculating the accumulated value, okay? So here is another way to calculate the compound interest that we just did in our example here, where we had 1,500 for 3 years at 7.5 compounded annually. So we kind of did this little visual chart, but here's another way to do it. So see how we have the growth factor here. So we're going to multiply that by the principal, and then we can calculate the, what amount you have in the account, okay? All right, so if we look initially here at year 0, so right at the beginning before any time passes, this is how much money you have in your account. So we have $1,500. Okay, and then the growth factor here, we're going to use I as the interest. So you're going to go on. So 1 plus, so if I write it up here, A equals principal, so 1 plus 0.75, there's our interest. Okay, so then it'll be that value. So you're going to take your principal and multiply by that value there. Okay, all right, so the first year there is no interest being added on. So in the next year, so we're going to go 1,500 times this number here. So you're going to go 1,500 times 1.075. Okay, so when you do that, you're going to get our first amount after 1 year. Okay, there it is. Okay, so again, I know some of you may prefer to just kind of do it this way because it makes sense, but if you prefer the formulas, you can do it this way. All right, so in the next year, you're going to take the previous amount that you had, and that's going to be your new P value. So this is your initial value that you start with. And you are now going to multiply that by our growth factor. Okay, and then make sure you round it properly. It's money because it was 4,375, so 44 cents. Okay, so that's after 2 years. Okay, so we want to go 1 more year. So again, we're going to take our value that we just had as kind of our start value for this year. And then we're going to again multiply by the growth factor. And then we end up with 45 cents, like that. Okay, so here is another way to quickly calculate the compound interest if you don't like kind of these little rainbow ways of calculating it and so forth. And it's a little bit more compact and nice and clean and so forth as well. So, okay, so now that we've finished one that was simple interest, another one that was compound interest, this is kind of where I want you to get to now. So you're going to have Larry here invest $700 for 5 years. He's going to put one, he's looking at both scenarios, and he's going to put, if he put money into a simple interest account, for 5 years, okay, for 4% per year of simple interest, or if you made the same investment into a 4% per year compounded annually, which, yeah, like we want to see the difference in how much money you end up making or he makes, okay? So let's do that here right now. Okay, so we're going to do this the visual way first, and then we'll use the formula. So in year 0, so like before we start, you had $700, okay, or Larry has $700. Okay, so 1 year later, we want to figure out how much money he has now. So we're going to calculate 4% simple interest. So 4% as a decimal, you divide it by 100, and you get to here. So I'm going to multiply by 0.04. Okay, so I'm multiplying this by 0.04. So then you end up with $28. Okay, so in the first year, you have $728 now in your account. Okay, so now we want to calculate how much we're going to have for our next year here. Okay, so after the second year, because it is simple interest, we go back and calculate the amount on the original amount that we added. So we just get 28 for the next year. Okay, so then we're going to add that to the 728 that we have. And we have now $756. Okay, all right, so another year later, we're just adding another 28. $784. Okay, so again, they're just going back to the original amount that you added and then just adding $28 every year. Okay, so we're at 812. And then one more year, 840. Okay, so if I change these to different colors here. Okay, so year 0, when you started, you had 700. 1 year later, you have 728. Okay, add another $28, 756. Another year later, year 4, and then year 5, now you're going to take the money out to use it for something, okay? So that's simple interest. So again, the interest is calculated on the original amount, and that's it. It doesn't matter how much you're accumulating. It just goes back to the original amount, so you always get 28 every year. Okay, so that's kind of the visual way of doing it. But again, I recommend being able to use the formula way as well. Because what happens if we're trying to calculate something that's, 30 years in the future and so forth. So the formula that we are using is this one here. Okay, so again, if we're going through and analyzing what stuff we're given and what stuff we need to find, so principal, that's the original amount, was the $700. The interest rate was 4%, but again, we're going to change to a decimal. And the time that it's spending in this account is 5 years. All right, so if we plug all of those in, so our goal is to find the amount, the future amount of our investment. Okay, so we're going to take 700 and then go 1 plus 0.04 times 5. Okay, bracket. All right, so BedMath says take care of this part first. Okay, and that becomes 0.2. Okay, and then now we're going to take care of this part here, add that. 1.02, and that's what we're going to multiply by. Oops, 0.2, sorry, 1.2. 1.2 times 700 is $840. Okay, so I wrote a lot of work there, but you don't need to write that many steps, I guess, if you can calculate a little more efficiently. But at the same time, if you prefer the visual way at first, just kind of get comfortable, and then eventually go to the formula method, that'll be good too. Okay, so we found how much Larry's going to make 5 years from now. Okay, so again, if we're just trying to figure out how much he made, so the interest, okay, so what we're going to do is we take our total amount, which is the 840, and then we subtract by 700. We'll get $140 in interest. Okay, so just for Larry leaving that money in the bank, he didn't have to do anything, he just left it there for 5 years. He made $140. Okay, Larry is also interested in putting his $700 into a compound interest account, so we're going to calculate that next. So I thought about doing this method here, but it's going to be 5 years and a lot of calculating on interest on interest on interest. So I'm just going to go right to the table here, just like we did above here, okay? Okay, year 0, so when we start, Larry is going to put in $700. Okay, so in after 1 year, so we had $700. We multiply it by our growth factor. So again, I is 4%. We're going to change it to a decimal, 0.04. So then this becomes amount equals the principal times 1.04, like that, okay? Because we're going to add 0.04 here, add it to 1, and get to that. So that's our growth factor, 1.04. Okay, so when we do that, we get $728, okay? Just like above, same in the first year. All right, but what changes is that we carry forward the $728 and use that to calculate our new amount, okay? So we're going to count the growth factor on that, okay? So when we do that, okay, we end up with $757.12. Okay, so keep going. Make sure to multiply. Okay, the 1.04. Okay, so we have, and so in the next year, we're going to carry forward this amount and use that amount to calculate the new interest, or the amount. So we get 787.40. Make sure you're rounding properly. Okay, if you're off by a cent here and there, it just messes everything up. So, okay, so I'm multiplying another 1.04 on that amount, and I end up with 90. All right, and this is the last year now. So we end up with $851, and so it goes 657, right? So 66 cents, like that. Okay. All right, so that's what you're doing today. You are going to calculate the simple interest and calculate the compound interest, and so we're going to figure out, okay, how much interest did we make here? Do that. Okay, so again, we ended up with 851. We originally had 700. So we get the interest made from placing his money into this account. So he made $151.66, where here he only made $140. So in the end, he ended up making how much more? So ended up being $11.60 more, okay? Okay, so since he makes it $11.66 more, this is the better account. So if you had a choice like that, you hear compound interest, definitely go with those accounts. The simple interest, it's just you're getting the same amount added every year, okay? So it doesn't matter how much the amount in the account is accumulating, it's just you end up with 28 regardless of how much, okay? Because you calculated it based on your original amount that you deposited. All right, but here it's great because if you keep your money in, it keeps piling on top of the new amount of money that you make, okay? On top of the 700 that you added. So that's why they call it compounding. It kind of just piles up on top of each other, okay? All right, so just go through and practice some questions like this. So again, hopefully you understand what's happening here with simple interest, that you could just use the formula. And then with compound interest, you can use the table here, okay? I'll try to keep the questions so that they're nice, not too many years, like 5 years. Even that was annoying to calculate, so maybe I'll keep it at 3. But we will look at, well, what's a better way of doing this tomorrow, where what if I say 30 years later, okay? Making a table like this for 30 years is really going to be annoying, so I'm going to show you a new formula that you can use tomorrow.